Open science, that's really a hot topic at the moment. It refers to a number of ways to make our research more trustworthy and, would you believe, more open. I'll mention just two aspects at this stage. One is that research needs to be reported in full, complete detail, and second, we need replication. Throughout the book there will be more. We'll be coming back to open science quite often, but the development of open science practices is going on at the moment, and it's maybe the most exciting sort of set of changes to the way research is done. So as you think about these things, be aware that you're up with what researchers are considering and having to come up against in their own work. Why? Well, triggered largely by the replication crisis. For example, a company, Amgen, wanted to invest in producing new cancer therapies, and it checked through landmark studies right at the forefront of cancer research published in top peer-reviewed journals and chose 53 that looked promising. And before it invested its money in clinical development, it arranged for all 53 to be replicated. Alas, the findings were basically only confirmed in 6 of the 53 cases. That's a shocking result. And there have been some other examples in psychology and other disciplines across science. Now, in general, science has been and is enormously successful, but these are troubling findings. Why? Well, I need to discuss the difference between two sorts of uncertainty. When we considered our poll and asked if we did it again, the same but with a new sample, would we get about the same result? Well, yes, and the amount of uncertainty, the amount of sampling variability from study to study is signalled by the confidence interval. And statistical analysis is set up to represent and cope with this sampling variability arising from the natural variation that happens if you choose a different sample. But actually there's additional uncertainty in this real world we operate in, and this requires careful thought. It's not really directly a statistical thing that we can calculate, but requires our judgment. For example, how was the sample chosen? Was the poll taken only, for example, with listeners to some particular radio program? If so, it's hardly likely to be representative of the whole population of likely voters. What was the procedure? Were there leading questions asked? What did the pollsters do about people who declined to respond or couldn't be contacted? Maybe we're only seeing the result of one of the questions, but other questions were asked, and so we're seeing selected results. Maybe even there were other polls taken, and whoever gave us the result selected which poll to tell us because it matched some political agenda. So open science first alerts us that the reader has to be beware. Our careful thought is needed as we consider any research result. And the best way to summarise this, I think, is with the slogan, do we have the full story? Having the full story means no selection of which study, we're told, no selection of which results out of a particular study have been reported. So we need fully detailed reporting of everything to do with the procedure, the sample, and preferably the full data. Then second, as well as having the full story of this study, we need replication. Only then can we build our confidence in some finding. Now, there'll be more about open science as we go through the book. It's one of the strong themes, one of the most exciting things happening at the moment, and we'll discuss many aspects. But for this beginning, think of open science as requiring the full story. As you read anything about research, you're asking, what am I not being told? How else could this be interpreted? Is this really complete and convincing? And so correspondingly, when you're reporting your own work, it's incumbent on you to tell the full story, to give fully detailed information about everything you did. That's good open science practice.